Well, hello everybody. I think somebody probably out there has been waiting for this. It's going to be a combustion tutorial on Ansys Fluent. As far as I know, I couldn't find any YouTube tutorials about this. So, with that being said, you're going to have to be patient with me because I am going to be doing this tutorial on the fly. I don't have time to do it twice, once off, I guess off screen or whatever, and like make sure I get everything right. I have to go ahead and do this from scratch in front of you, so kind of like live action. Go ahead and open Ansys Workbench. Another thing is that I am going to be modeling on SolidWorks, just a random gas combustor design that I'm going to make up, gas can combustor design I'm going to make up, and what I'm going to do, there are several different ways of doing it. Not that. So let me just show you what I mean. This is kind of similar to what we might be getting in the results section. If you don't know what a gas can combustor is, they are basically like very large, somewhat deformed soda cans with, you've got a main air inlet, then you've got fuel inlets, then you've got, thank you Ansys. Then you've got cooling air also coming in from the sides. What I'm going to do is the following. Let's go ahead and get right into it. Gosh. Again, I'm working on a ghost drive, so it's kind of aggravating. Sometimes it's a little slow. So I'm going to go ahead, as I said, make a model in SolidWorks. So what I was going to say is that there are different ways there's so many ways of doing this kind of simulation. The first difference that you might find is that I'm going to model the fluid, right? And that's going to be my computational domain. Now, another way of doing it, actually a somewhat better way of doing it, is to model not the fluid domain but the solid, right? So model your combustor in SolidWorks, then import it into Workbench, and then in Workbench make a do the fill, basically fill by caps. And what you can do is, gosh, this is slow. Are you guys watching this? I'm like, well, anyways, so you'll import the actual physical metal gas combustor model into Workbench, and what you're going to want to do is fill it, not fill it like fill at the edges, but fill it with the fluid. And there's a I'll try to show it to you later on. I won't do it, but I'll show you where the command button is to basically fill it with fluid. You tell the program where the two caps are, where's like the inlet or exit, and there can be several of those if you want. And then then you've got a solid and a fluid domain, right? And then when you go into simulation, you're going to have to state that there is a wall, an interface. If you guys have watched any of my other tutorials, let me go ahead first. I want to make sure that I'm in metric because I want to do this in meters. Yeah, I was not in meters, so okay, so now I can go ahead and do that again. So anyways, if you watched any of my other videos, you should know that you know, if you've got a metal and fluid, a solid and fluid in contact, those surfaces in between, you have to name them interfaces so that the program knows it's an interface. So 0.7 meters, enormous. Yeah, we'll find out if that's okay. So then the other thing, this is going to be like kind of my you'll see what I'm trying to do in a second. Just alright, that's cool with me. Now what do I want to do? Yeah. Okay, so now what I'm going to do is exit the sketch, and I am going to extrude this. Okay, I could do it like this too. So I'm gonna make it like in enormous, not the diameter. Yeah, there you go. I'm gonna make it really large and long, and the reason why is because when you start making things smaller, you guys know you have complications with the mesh, and especially with combustion, it's really can be a pain sometimes to get combustion simulations to work perfectly. So I'm gonna go ahead and once you see what I'm trying to do, you'll maybe understand. Yeah, from behind. Cycle. If I sound weird, it's because I have a sickness. I am ill. I got like a cold or something. Let me see. You know what I really should have done? This is gonna look retarded, but I'm gonna extrude this also because I kind of did this backwards a little bit, but that's okay. Let's do like up to next surface, up to surface. Is that gonna be right? I don't think so. Yes, looks okay. No. Well, whatever, I can just put 5 here, blind, and 5, and there you go. Okay, cool. So now we have a solid cylinder. And now what I want to do is I'm going to extrude, because you have to remember I'm not making the solid, I'm making the fluid, so it's kind of strange. You have to be able to kind of think about it in a weird way. So instead of like making the front plate here, what I need to do is extrude ever so slightly, actually extrude cut this like 0.5. Did it do it? I don't think it did it. No, it didn't do it. Okay. Alright. Another thing that's kind of a pain is that I've got this mouse that just is not really working with me. I don't understand why blind didn't work, but you know, it did work. And okay, well, it might have helped if I was looking in the right direction. Let's look at that. Let's do that, but then that's way too big, so I have to do like 0.25. Still too big. Let's just do 0.15. Alright, that's reasonable. So now we have to I'm gonna quickly make make a sketch on this plane, and you know what I need to do is I need to make the little inlets for the fuel to come in. So just make like one here, right? And alright, so this is kind of where like I'm really gonna maybe upset some people if I haven't already. And the reason why is because really I should obviously know all these dimensions and have put this in and should be okay. The reason why I should know these dimensions, the biggest reason why, is because when it comes down to calculating things like the mass flow at each of the inlets and like how much power in like latent energy is going through, or every fuel has like a limited heating value and or a higher heating value, and based on those numbers you have to decide how much fuel is going to go into each of the nozzles by doing a teeny bit of thermodynamics. So we've got this one. Now I'm going to go ahead and do a circular and do this, and I'm gonna do, what do you guys think, 6, 8, six is good. Alright, so six of those, and I'm sure there's a faster way of doing it, but I am going to make dimension driven, adding dimension will make sketch over defined or under. Do you want to add this in? No, I don't. Okay, so cool. We've got little fuel inlets now, and now I'm going to do slightly larger air inlets. This mouse is driving me crazy because like I'm trying to move around smoothly and it's so jittery. Jittery. Alright, I have six of those. And you know, like 4, let's go with it. Alright, so we are very happy with that sketch, and now I want to extrude out these little faces. And it knows, actually. Awesome. So it knows what I'm talking about. And let's like just rotate ever so slightly. So that's a bit too much. So let's just do like 0.05. And that's probably going to be enough. Yeah. Alright, so I don't know if you guys can see it, but I'm an idiot and I haven't saved yet. Let me go ahead and save really quickly. Okay. Just save that. I'm gonna delete it after the tutorial anyways. So, I don't know if you guys can see it, but what we've done is made in a ridiculously basic Combustor geometry, and it's a little bit it's too long, and I know that, but what you know, I expect the flames to end around here, but this is gonna kind of speed up the processing time in a way, because I won't get an error where for the outlet, because I'm gonna make that face over there the outlet, be it like a pressure outlet, probably not an outflow, but I'll make it a pressure outlet, and this is going to be super turbulent area. Now, okay, so here we are. We can finally move on to what we want to do. And in Workbench, we're going to go ahead and open the fluid